Hello class, this is Mr. Sutton. Sorry I could not be there for today's lesson, but hopefully this video will help you get through. Go ahead and get started on the bell work, which is the front page of the packet, and the second page as well, up until we get to the quick notes. So continue on first two pages, go ahead and pause the video, work on those, and when you continue the video, I will go over the answers to that. All right, so let's look at answers here. So for this activity, for this we want to use digits 1 through 9. And so we need to have two parallel lines, and then one line is a transversal. So here the 1 and 2 need to go here, and then the 3 and the 6 need to go here. So that way we have two parallel lines. I think there's other things you could do that would work. Maybe if you had a 4 and 8 here rather than the 3 and the 6. That way those lines would be parallel as well. But you want to make sure you have two lines that have the same slope. The other numbers can kind of fill in where they need to. So we have the 5, 7, 8, 9, and 4 here. Again, I don't think yours need to be exactly like mine, but we do need to make sure we have two lines that simplify to have the same slope to make them parallel. And then task 2, using the digits 0 through 9 at most one time each, fill in the blanks to create a set of 4 points that create either parallel or perpendicular lines depending on how you connect them. So here we did 1, 3, this point, 2, 4, this point. So these lines these points have a slope of 1 between them, and then 3, 6 here, 4, 7 here. These points have a slope of 1 between them. So these two lines would be parallel to each other, and then these points have a slope of 1, 2, 3, 1, 2. So that would be 3 over 2, 1, 2, 3, 1, 2. So these 2 points have the same slope as well. So those would be parallel to each other as well. Other things you could have put there, I'm sure, especially none of these are perpendicular. So if you were going to perpendicular lines, you would have something else as well. Based on the exercises 1 and 2, what rules could you come up with regarding parallel and perpendicular lines? So if the slopes between the 2 points are the same, the lines are parallel. Opposite reciprocal slopes are perpendicular, which we should know from last lesson as well. So your quick notes now onto that. Parallel lines have the same slopes. Example, y equals 1/2 x plus 2 and y equals 1/2 x plus 3 are parallel. Perpendicular lines have opposite reciprocal slopes. So example, y equals 3/5 x plus 2, y equals -5/3 x plus 4. Point slope form, if given a point and you know the slope, you can use y minus y1 equals m times x minus x1. For the x1 and the y1, that's where you'd plug in one of your points, and then the m, that's where you plug in your slope, and that should give you your equation for that line, just given the point and the slope, and then you can solve for y equals mx plus b after that. Slope-intercept form is the y equals mx plus b form. So that's good if you're given the slope and a y-intercept. You can just plug those in, and then you have your equation there. So now you can go ahead, once you have that down, work on the check for understanding. And then you can, once you've completed that, continue the video, and I will go over those in just a moment. So create an equation of a line that is perpendicular to this line. So you need to make sure you have the -7/2 as the slope. That's the opposite reciprocal slope. You can put in any b value, any y-intercept there, doesn't matter, as long as you have the right slope. Create an equation of a line that is perpendicular to the line y equals 2/7 x plus 5. So our new slope is going to be -7/2. But this time this needs to specifically go through this point 3, -5. So given a slope and a point, we want to use point slope form here. So we plug the slope in for m, and we plug 3 in for x1, and -5 goes in for y1. So we have y minus -5 equals -7/2 times x minus 3. So that would be our equation here. We can change the minus negative to plus positive. It doesn't ask for us to put it into slope-intercept form, so this is all we really need to do here. But sometimes you might get this question where it asks you to put it in slope-intercept form, in which case you would need to solve for y. Find the equation of a line that's perpendicular to this line through this point. So you need to find the slope of this line first. So we would need to subtract 4x on both sides and then divide by -4. And you get y equals x minus 10. So if we want a perpendicular line, the perpendicular slope is going to be -1. And then it needs to go through this point. So -1 is also our x1 value, and then our y1 value is 0. So we plug those into point slope form. We get y minus 0 equals -1 times x minus -1. Y minus 0 just simplifies to y. X minus -1 simplifies to x plus 1, and then we distribute the -1 from there. So we get y equals -x minus 1. So that would be option D. For the lines represented by the equations 2y plus 3x equal 10 and y equals 2/3 x minus 10 are perpendicular to each other. If we find the slope of this line, subtract the 3x on both sides, divide by 2, you should see that this line has a slope of -3/2, which is opposite reciprocal to 2/3. So these are perpendicular to each other. And then we have the challenge question for honor students. Q is the point -2, 8. R is the point 4, 5. S is 6, 9. And T is x3. So we don't know what the x value is. We do know it's at a y value of 3. So somewhere in this horizon, we want to find the value of x that makes QR perpendicular to T, or to ST rather. So we want to use the graph here, and we want to draw a point, or draw a line from Q to R, and then from S through R, and then we want to continue on with that perpendicular line until it passes through y equals 3. And then that intersection of the line y equals 3 and this perpendicular line would give us our point. So that would be 3, 3. So that is all I have for you for notes. So you can work on the IP now, and I will see you next class. Have a good day.